Hello and welcome to Reill's tutorial. Today's topic will be on solving problems in vector and scalar quantities with the emphasis on magnitude and direction. In one of our previous lessons, vector and scalars was explained. The link to the vector and scalars explanation is provided up above. Okay. Note: the problems we are about to solve were derived from different books, and they are: we have the AP Physics 1, AP Physics 1 for Dummy, and Physics 2 for Dummy. The link to this reference book will be provided in the description below. Okay, now let's dive in. Now let's solve some of the questions that we have here. The first question is: let the vector A, B, and C be defined as. We have a vector A, B, and C. We have vector A, B, and C, and this is A, B, and C. And now we have it that the first question says, what is the magnitude of A? So for us to solve the magnitude of A, we have A in terms of magnitude will be equals to the square root of AX square plus AY square, and that would be, what is our AX? That is this 3i, so it will be the square root of 3 square plus the AY is 6 plus 6 square, and that will be equals to the square root of 9 plus 36. So therefore 9 plus 36 will give us 45. So for us to find the square root of 45 would be 6.7. So therefore the magnitude of A is 6.7. That's how to solve the magnitude of A. Sketch the vector subtraction problem B minus C, and find the components of the resonant vector. So first, let's sketch the vector B minus C. Okay, so we have, this is B minus C, that means they're driving in different direction. So let's assume B drives up this way, then C goes in the negative direction this way. So this is B, and this is C, negative C. Then the resonance here will be B minus C. So this defines B minus C. So if the questions here says, we scroll up, find the components of the resonance vector. So for us to find the components of the resonance vector, going back down here, we'll have, what is B? B is equals to B minus, for us to find the resonance of B minus C, it will be equals to, if you look back at the question, we have B is minus I plus 4j, and C is 5i minus 2j. So let's scroll back down and spread that out. We have B is I B is I minus I plus 4j, and C is what? And C was 5 minus 2j. 5 minus 2j. So for us to get the resonance of these, then we put the like terms together. We put the like terms together, because if we come up here, we'll see here that I minus 1i and 5, they are like, and 5i are like terms. Then 4j minus 2j are also like terms. So that's what we're going to resolve here. That's the resonance. So we have it here that B minus C be equals to minus I, then this minus 5i, then plus 4j minus 2j. Okay, so that would give us this minus I minus 5i is equals to minus 6i, and minus 2 is equals to plus 2, plus 2 plus 4 is equals to plus 6j. So this is the resonance of B minus C. Now, the next question says, find the component of A plus 2B. That's what we're going to look for now. Find the component of A plus 2B. So we have A plus 2B. Okay. So first, what is A? And we know that A plus 2B. First, let us write out what is A. A here is 3i plus 6j. Okay. 3i plus 6j. This is A. Plus 2b is what? 2 is negative I plus 4j. Negative I plus 4j. So we have 2 brackets negative I plus 4j. So in that sense, this B is this bracket, then the 2 is what multiplies it. So for us to solve this out, we have it as 3i plus 6j bracket plus 2 times minus I will give us 2 negative 2i. 2 times 4j will give us 8j. All right, so now we have it as 3i plus 6j plus bracket minus 2i plus 8j. Okay, so now for us to solve it out completely, we take the like terms. So it will be 3i minus 2i plus 6j plus 8j. 3 minus 2 will give us 1, so that is A plus 2b is equals to I plus 6 plus 8 is 14j. So this will be the answer for that. Okay, now the last question says, express A minus B minus C as a magnitude and angle relative to the horizontal. Let's try and work that. A minus B minus C. So right now we have A minus B minus C. So now what is A? And we know that A is equals to 3I plus 6J, 3I plus 6J minus B is equals to, I think it's I minus I plus 4J minus I plus 4J minus, and C is equals to 5 minus 2J. 5 minus 2J. So for us to solve this, we'll put this in like terms. That means 3I minus I minus 5I plus 6J minus 4J minus 2J. Okay? Now let's solve it out. So for the i's, 3I minus I is equals to 4I minus 5I will be equals to I. Then plus 6J minus 4J is equals to 2J minus 2J, that's equals to 4J. Right? So now for us to find the magnitude of this, let's say this D, magnitude of D, that is D will be this A minus B minus C. And that would be, like we explained before, dx square plus dy square. And the x here is I, that is 1 square plus the other one is 4 square, square root of that. So that will give us 1 plus 16, and that is root of 17. So to find the square root of 17 is 4.1. So this is the magnitude of A minus B minus C. The other question now says, and also find the angle relative to the horizontal. The angle relative to the horizontal, that is the direction of D related to the horizontal, is what? So theta equals to tan inverse 4 over 1. Because here we have 4 here as this value, and this one was negative 1 as this value. That's 4, negative 1. Because if you look at these calculations up here, it's supposed to be negative 1. 3I plus is equals to 4I minus 5, that is negative I. So we come down here, we have it as 4 over negative 1. Find the tan inverse of 4 over negative 1 is approximately 76 degrees. So therefore, the angle is 76 degrees and the resonance, the magnitude is 4.1, right? Okay. So this resolves those problems that we have here. Okay. So now let's solve another problem. An ant walks 20 centimeters due north, 30 centimeters due east, and 40 centimeters northeast. Assuming that each portion of the ant's journey is a vector, sketch the ant path. Now let's sketch it. So the ant walked 20 centimeter, let's call this C1, due north, 30 centimeter, let's call this C2, due east, and 14 centimeters, let's call this C3, northeast. So this is a sketch of how the ant path moved. The next question now says, how far has the ant traveled from its original position? This is the original position, and this is where the ant is right now. And this original position says it travels north. It goes up. If you remember from our graph, the graph is this way. When we say north, we're talking about the y part, and this is the x. So when we say something traveled north or south, you're looking at the y-axis. When you say it travels east or west, looking at the x-axis. Then now this c is traveling between the north and the east, so it's going between x and the y-axis. So for C1, the next question says, how far has the ant traveled from its original position? So looking at the distance the ant has traveled, right? So let's say distance D is equals to C1 plus C2 plus C3. And the C1 is not, C2 is C1 is Y, C2 is X, then C3 is between the X and the Y. So now let's solve for C3 first. C3 is between the X and the Y. So we have C3X1 would be C3 cos. Since it's at the angle of between the north and the south, northeast, that is 45 degrees. That'll be C3 cos 45 degree, which would be approximately 10 centimeter. So the 10 centimeter is towards the x-axis. Then C3Y1 will be C3Y1 will be what? C3 sine, we're looking at the y-axis now, sine 45 degree. And sine 45 degree too is approximately 10 centimeter too. So in this form, we now have D, we have C1 is equals to, what is C1? C1 will be, since what C1 is going through the north, so it will be 0x, doesn't have an x, plus 20 that is going to the, what is going to the north again? I think it was 20, or was it 10? 20 to the north. Then 20 will be for the y. You see? Then C2 would be, this is going east and at 30. That's 30 to the x plus, no, it doesn't have a y. Then now C3 is equals to 10 for the x and 10 for the y. Okay? Now let's go further down. The question says, what is the distance D? So right now we have D is equals to C1 plus C2 plus C3, which will be 0x plus 20y plus 30x plus 0y plus 10x plus 10y. Okay. Then for us to explain further, let's put the like terms together. And then for D, the distance would be 0 plus 30 plus 10. All of these are on the what? On the x-axis side. This is the x part that defines the x part. And plus for the y, we have 20 plus 0 plus 10. Okay? So D would be this plus this plus this, that is 40 on the x side plus 40, This is plus 30 on the y side. We know this x and y. Now, look at the question. It says, if you look at the question up here, it says, how far does it travel from its origin? And we're looking at it as a vector. So we're looking at it as a vector. Instead of calling it x and y, vectors would be the I and the j. So the d is 40i plus 30j. And now for us to find the distance, that is the magnitude of d would be dx square plus dy square, which is equals to 40 square plus 30 square root of that. Then we scroll all the way down. Then we find the square root of this. This one is 160 plus 90, 160 plus 900, and that would yield square root of 2500 centimeter square. Therefore, the distance now would be 50 centimeter. So the distance between from the beginning to the end, how far it travels is 50 centimeter. Now it says, if this ant does not want to travel further than 80 centimeter from its origin, how much further north can it walk? So it doesn't want to travel 80 centimeter further from its origin. And we know that the distance, the vector's distance here, we know that d was 40i plus 30j, and that was how we derived this 50 centimeter. So now, if you are telling us that it doesn't want to travel further than 80 from the origin, 80 centimeters from the origin, what will now the d here? Centimeter. Now it wants to go further to 80. Now the ant wants to get further to 8 centimeter, but not we can solve that. Now we have, let's call this let's call the final position of the vector, let's call this b. Final position of the vector, let's call it b. And the final position of the vector is 80 centimeter. Okay, so for us to get this b, how they got the b would be bx square plus by square, which is equals to 80. And we know that from here, this vector of d, we have 40 as the x. So 40x plus this y doesn't want to move, doesn't want to go further. So this one will just be what we are looking for. This will be y square. That's what we are looking for. So this will be 4 square here. So for us to get that value, we'll break out everything. So it will be 80 square minus 40 square, or we can get by square. Then 80 square minus 40 square would be minus 1600 is equals to by square. So for us to get by would be the square root of the value we have here. The square root of this value, and that will be about 69.3 centimeter. So the Fy, the By will be 69.3 centimeter. So for the ant to move to get to 80 centimeter, so it has to move 69.3 centimeters north. It has to move and also move 40 centimeters east for it to have a total of 80 centimeter. That is what that is saying. But now, since the ant has already moved 30 centimeter initially, because initially the ant has already moved 30 centimeter initially, not. So how much further does he have to increase his step to get to the 69.3? So it will be 69.3 minus 30 centimeter, and that will yield 39.3 centimeter. So it has a much more step. That is, for the ant to get to 69.3 centimeter, it has to increase the step by 39.3 centimeter. Let me draw that graph again, because initially we had it as C1, then C2, then the knots of C3. So for this C1 to go further, to be C1 plus the additional, plus this additional 39.3 centimeter. Okay. So that explains the question. That solves the question that we're trying to solve there. Okay, so this solves the questions here. So this is the additional steps the ant has to take, 39.3 centimeter. Okay. Now let's look at other problems. Now this says, as a boat travels in a river, its velocity v is determined by the current c and the relative velocity compared to the river r. For instance, at one point in the boat's journey, these vectors are related in the following way. This is the c, this is the water path, then this is the vector. This is the velocity v. Write a vector equation that shows that v is related to c and r. Since v depends on c and r, so it makes sense for us to say that v is a resonance vector. That means v is a resonance vector. That means v is equals to r plus c. So that is the equation. Since v depends on c and r. That is the question for number. That's the answer for the first one. Just v is equals to r plus c. If the angle between v and c is 90 degrees, this angle here is 90 degrees, as shown, write an equation for the magnitude of v as a function of c and r. So if the angle between this is 90 degrees, so the equation of that would be v squared plus c squared is equals to r squared, because vc, this is going to be the r part of it. Okay, then that would be v squared will be r squared minus c squared. Therefore, v squared would be the square root of r minus c. So that would be the equation between v as a function of c and r. This will be the answer. R minus c. V will be equals to square. V square will be the square root of r square minus c square. Let me write it clearer underneath here. So v will be the square root of the r square minus the c square. Okay. So the next question now says, If at a different the boat's journey, if the current is flowing due east 5 meters per second and the boat wants to travel 10 meters per second, what should the captain set its relative velocity to be in magnitude and direction? Now, applying this, we have R is equals to V minus C, because we're looking for the relative, says the relative velocity, and that is R. What should the captain set its relative velocity? That is what we're looking for. Relative velocity is V minus C, okay, which is equals to, we have the V minus C. We have to set it at 5 meters per second and 10 meters per second. So 5 meters per second is, that is I, then 10 meters per second not. That's how it wants to go. So we have it as brackets. The V here, V is equals to negative 10 meters per second, and the C is equals to 5 meters per second. So since the C goes east, so it's 5 meters per second I, and the other one goes north, is 5 meters per second J. All right. So now for us to solve this out, the relative will be V. We only have J, we don't have I. Be 0 minus 10J is I. Then minus for C, it is 5, right? 5I minus 0J. So now let's take their like terms. So the R will equals to I 0, 0I minus 5, 0I minus 5I plus minus 10J minus 0J. Okay? And that will give us R is equals to negative 5I meters per second, negative 10J meters per second. So that will give us the relative vectors. This is the relative vectors. But the question still says up here, it says, find the relative, what should the captain set its relative vector to be in magnitude and direction? So now we got that one we got in first defines this part for us. So now let's find the magnitude of this relative. So the magnitude of R will be equals to Rx squared plus Ry squared, which is equals to square root of negative 5 square plus negative 10 square. Therefore, which is be equals to what? This will give us 125, and that is 5 root 5. It can be approximately 11.2 meters per second. That is the magnitude of the relative vector. So now for us to find the direction, therefore theta will be tan inverse 10 minus 5, and that would be 116.6 degree. This is the direction. Okay, so that's the end of today's class. Please don't forget to like, share, comment, and subscribe to this YouTube channel. To the next class, I will solve other problems. Thank you and see you soon. Bye.